Indices and logarithm. Now let's start with indices. Laws of indices. We write a times a times a times a as a raised to power 4, and more generally a times a times a up to a times a, the product of n as a raised to power n. Thus, if we have something like a raised to power m times a raised to power n, it means equal to is also the same thing as a times a times a to the number of m times a times a times a to the number of n, where the first bracket contains m a's and the second bracket n a's. So their product is the product of m plus n, since they are counting the a's inside the bracket. Thus, the first law is as follows: a raised to power m times a raised to power n is equals to a raised to power m plus m. This is our equation 1. Anytime there is a multiple of, if they have the same base, that is, if they have a and their superscript is different, then we now plus the two superscripts, that is a plus m. It will also give us the same answer as a times a raised to power m times a raised to power n. Second law of indices. Hence, dividing a raised to power m plus n over a raised to power n, it will give us a raised to power n, because it will be equal to a raised to power m plus n, all in bracket, minus n. Therefore, a raised to power p divided by a raised to power q is equals to a raised to power p minus q. So once there is division, we subtract. Anytime there is multiplication, we add their superscripts. So that when multiplying, we add the indices. When dividing, we subtract the indices. Third law of indices. Extending our multiplication, we have also in bracket a raised to power m in bracket a raised to power n is equal to a raised to power m times a raised to power m up to n times, which is also implies will give us also a raised to power m n. This is the third law of equation, or we say this is our equation 3. Negative and fractional indices. A raised to power m divided by a raised to power m give us 1 for all m, yet when we subtract the indices, we have a raised to power m minus n, which will give us a raised to power 0. Therefore, anything a raised to power 0 is equals to 1. This is our fourth law of indices. Anything raised to power 0, 1 million raised to power 0 is 1. 100 million raised to power 0 is 1. 10,000 raised to power 0 is 1. Infinity raised to power 0 is 1. Also, a raised to power m times a raised to power minus n is equals to a raised to power 0. This will give us 1. Therefore, a raised to power minus m is always equals to 1 over a raised to power n. This is our fifth law of indices. Anything having a negative power raised to power is 1 over, or inverse of that power. Note, if in bracket a raised to power m raised to power n is equals to a raised to power p, where p is equals to mn, a raised to power m is the nth root of a raised to power p. That is, a raised to power p over n is the nth root of a raised to power p. Since strictly a number may have more than one nth root, we say that a raised to power p over n is one value of the nth root. So anything over division means root. Example 1. Without the use of table, calculate the value of n in the following: a. 3 raised to power 0, b. 3 raised to power minus 2, c. 27 raised to power 2 over 3, d. 27 raised to power minus 2 over 3, e. 8 raised to power 2n equals to 1 over 64. Solution. In answer to the number a is 0 according to the fourth law, we say that